In this video, I'll talk about the forces between electron and a proton. And the forces that we're going to compare is the gravitational force and the electric force. The gravitational force exists between any two masses, and the electric force exists between any two charges. The simplest case or the simplest atom we can have is the hydrogen atom, which has one proton and the one electron here. So now we have one electron and one proton here, and we're going to compare the electric force between the electron, proton, and the gravitational force between the electron and the proton. The known parameters are the mass of the electron, which is here, the mass of the proton, the charge of the electron, and the charge of the proton. And notice here the charge of the electron and the proton has exactly the same magnitude, but the magnitude of the charge on the electron is negative, and the charge onto the proton is positive. So this P stands for the proton, and E stands for the electron. Me for the mass of the electron, and Mp the mass of the proton. The distance between the proton and the electron is r, which is this number here. And here I'm adding up one more constant quantity, that's the universal gravitational constant. If you have taken the University Physics 1, you should be familiar with this number here, 6.67 times 10 to the minus 11. And here I'm going to throw out one more, the constant here, that's K, and this value is 9 times 10 to the 9 Newton meter square per Coulomb square. That's the constant. So now let's find out the electric force and the gravitational force. First we'll start with the electric force. The electric force between the two charges is given by the Coulomb force, which is this equation here. K, as I mentioned, is a constant, and this constant is for the free space. And here, as the charges are in free space, we're going to choose this value. And remember, if we put the two charges into some other medium, let's say in water, then this constant will change. Okay, but for most cases we'll be dealing with the charges in free space. And Q1 and Q2 are the magnitude of the charges. So those are the charges of the electron and the magnitude of charge of proton. The K value is 9 times 10 to the 9. The charge of the electron is 1.6 times 10 to the negative 19. The same as the charge of the proton is 1.6 times 10 to the negative 19. R, which is the distance between electron and proton, is given, and it is a square here. If I solve this one, then this will give you this number here, 9.216 times 10 to the minus 8 Newton, which is very tiny in compared to the weight of any object we see around. Okay, so this force is very small if you compare the weight of a 1 kilogram object or any object, even compared to the weight of a piece of paper. So this is very smaller compared to the weight of an object. But now let's compare the gravitational force here. The gravitational force between the electron and the proton. So here I'm just choosing M1 as an electron and M2 as a proton here. So the G value, which is a universal gravitational constant, is given right here. So just plug in all the values, and I'm calculating now the gravitational force, which is now 4.01 times 10 to the negative 47 Newton. So far we mentioned this force is very tiny if you compared to the weight of a 1 kilogram object or even one gram object. But now when you compare this electric force with the gravitational force, the electric force is huge compared to the gravitational force. Let's calculate by how much. So the ratio of electric force and the gravitational force is given by this. This is the ratio. So we have this number here, and then for Fg, I'm just plugging on this value. I'm taking the ratio. So what does this ratio tell you? This ratio tells you the electric force between the electron and proton is 10 to the 39 times stronger than the gravitational force. So the electric force is so greater, much greater than compared to the gravitational force. And this is due to this reason that whenever we deal with the electric force between the two charged particles, we simply ignore the gravitational force. And the reason is the electric force between the two charged particles at a shorter distance is very huge compared to the gravitational force, and that's the reason we do not even bother about calculating the gravitational force between the two charged particles. Okay, so the electric force is 39 times stronger than the electric force. This has to be the gravitational force, 39 times stronger than the gravitational force. Gravitational force. Okay, so in general we calculate the electric force for the shorter distances, and the gravitational force becomes significant between the two astronomical objects, just like the earth and the sun, earth and the moon. There the gravitational force is so significant because the mass is so huge. But if we just calculate the gravitational force between the two tiny objects, it is insignificant compared to the electric force. So this is it from this chapter, where we have compared the forces between the gravitational and the electric force. Again, if you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.